Okay, so we're doing example 3 from your book. We've written the question down. 2 cos squared 2 theta minus 1 is equal to negative cos 2 theta. They want you to solve it such that it's between 0 and 2 pi. So in other words, they want positive solutions and to the max of 2 rotations. So that's when we're thinking of our CAS system, first of all, right? It's not quite a straight line, but we have our CAS system, so C-A-S-T. We're dealing with cos. So after we factor this all out, let's go on the assumption that we're going to have a cos as part of our answer. So in other words, we're going to be dealing with angles in cos quadrant, so the fourth quadrant here, and the first quadrant, because everything's positive there. So that's where cos and all okay, so back where we were. So we were just talked about being positive in the second quadrant and the fourth quadrant. Now what else is important here is we've been dealing with factoring. So in order to factor, we want to be setting our equations equal to 0. That way we can solve for whatever missing variable we have. So in other words, what I need to do is I need to be moving this negative cos 2 theta to the other side of the equation. So when I did that, when they do it, you'll notice what they did is they moved it almost into the second slot. Now remember, it comes positive when it's over here, minus 1 equals 0. The whole reason they set it up like that is if you remember factoring, and just quickly give you a little recap here. Ax squared, if we're dealing with quadratics, plus bx, so it's not squared, plus just c. Okay, so in other words, here's our c. This is our b at x. Our x we'll call our 2 theta here. Okay, and ax squared, if you notice again, this is our a. Our x is our 2, and we have our cos squared. So we're dealing with the second squared here. So in other words, you could technically, if you want, have you ever done any equations where they say let, that's not how to spell let. Let x equal, you could say cos, and well, all you're doing here is making it a little simpler to look at. So you could say something like let x equal cos. So then you end up with 2x squared 2 theta plus x 2 theta. Oh, I've made this backwards. I wanted to make 2 pi squared. But anyways, it's the same idea. Essentially the idea here is, see, I've gotten rid of the cos. I'm now dealing with x squared and an x, which is not quite what I wanted. I should have done the 2 theta. But the whole idea is making it simpler to look at. So it looks a lot more like a quadratic. So we can get rid of that part for now. But that's the idea. That's one way. If you ever get stuck with these and you're not sure where to go, you can say set something equal to x so that it looks a lot more like a quadratic expression. Okay, so we've multiplied the a value by the c value. Our b value was 1, and we know that we had our negative 2, so we split these open. So now we have 2, and well, what's your next step?
And you group them together.
Yeah, so we set this group and our second group together. In our first group, what can we find as a common?
2 cos 2 theta.
Yeah, 2 cos 2 theta. 2 cos 2 theta outside the brackets. So what will that leave this as?
Cos 2 theta.
Cos 2 theta. Subtract
Negative 1.
-1 plus.
You can't do anything.
Yeah, essentially it's actually, you could say you could take 1 out. That's the idea there. If I take 1 out, nothing's going to change. Equal 0. And now we can set up our 2 brackets, right? So we have our 2 brackets. One of them says, well, color them. This will be our first one. We'll set that group together. So our first one is 2 cos 2 theta plus 1. And our second set of brackets, since these are the exact same, we can just leave it as 1. Cos 2 theta minus 1 equals 0. So let's put this back in black. So 2 cos theta plus 1 minus 1 equals 0. Okay, so what would you do from the next step? Do you know?
You set the to 0 to find the roots.
Yeah, so we're going to split both of these. We're going to set up with two equations. So we have 2 cos 2 theta plus 1 is equal to 0. And we have cos 2 theta minus 1 is equal to 0. So we're going to solve for two separate equations. So let's go through our first one, the one on our right. What would we do over here?
Bring the negative 1 over to be equals to the equals 1.
Mm-hmm.
And then the second one will be equals to the equals to half. Forgot one.
This one here?
Yeah.
You brought the 1 over, or you did it all in one step?
Yeah, step.
Good. But there you see that you bring the 1 over, so it becomes negative 1. And we also had to divide everything by 2, so it becomes negative a half. So we have cos 2 theta is equal to negative a half, and cos 2 theta is equal to 1. Okay?
Mm-hmm.
So we made a little error in our factoring. This should have been positive 2, and this should have been negative 1. So this should have been a positive, that should have been negative. So essentially, what that works out to is when we go down here, these two signs should be flipped. This should be a negative, and this should be a positive. So that one that comes over, that's negative, and this is positive. Okay?
Mm-hmm.
Does that make sense?
Yep.
Alright, good. So we solved our little dilemma there. Okay. Now we're going to deal with special triangles. Do you know your special triangles? There are two major ones.
Two.
Yeah. We have our two major ones.
One
And
is like
we have root 2,
yeah,
1 and 1. And you know what the degrees are in those? This is a 45 degree, and this is a 45 degree. And our other triangle, well, this one looks similar, it's not to scale, obviously. We have 60 degrees, we have 30 degrees, and we have 90 degrees.
Mm-hmm.
The difference here is we have 1 root 3 and 2. Okay? So these are our two special triangles. Now, the first thing they've done is, if you notice, they decided to deal with this specific answer over here because it can be set up as a special triangle. They're asking for cos 2 theta is equal to 1 over 2. So in other words, I need to figure out which of the angles where my cos, our cos is, cos whatever the theta is adjacent over hypotenuse. Well, a hypotenuse of 2 works out here, and adjacent side of 1 would be this. So we're talking about this specific angle here. Okay? So they're talking about that specific angle there. Only thing is we're working in radians right now. Okay? So instead of being 60 and 30, our radians, if we remember, 180 is pi, and 2 pi is 360. So we'll just write a little note on the side here. 360 is 2 pi. That means 90 degrees will be pi to the half. Half of 90, which would be 1 over 4, is 45 degrees. So that's going to be these two. Over 4. Over 4. This one, 60 should be 1 over 3, I think.
Yeah.
And this should be 1 over 6.
Yeah.
Yeah, okay, good. So we replace it with 1 over 6 and 1 over 3. Alright, so what we can do now is we can set it up so that we are going to replace our 1 over 2 cos pi. We're going to get rid of the cos because we know that cos to this here is dealing with this specific angle, or this radian, pi over 3. So what I'm going to do now is I'm going to replace the cos 1 over half. I know that that is equal to pi over 3. So this question now becomes, I leave the 2 theta is equal to pi over 3. Okay? And the question says to solve for theta. So I'm going to divide both sides by theta. I didn't need to put an equal sign I'm going to divide both sides by 2. So this becomes theta is equal to pi over 3 by 2. When we divide by each side by 2, the 2 goes along with the fraction. That makes sense?
Yeah.
Okay? And we end up with our theta over 6. So essentially, what was very important here is when we switched from this question, our cos 2 pi is equal to a half, we figure out, our cos theta is adjacent over hypotenuse. And when we looked at our special triangle, our hypotenuse is 2, adjacent is 1, we're dealing with pi over 3. So I'm able to drop the cos equal to 1 over 2 and replace it with just pi over 3. I know that pi over 3 or 60 degrees is what we're talking about. And then the last step is I had to get rid of the 2 theta. So I know that 2 theta was equal to our pi over 3. We solve for that, and then all I have to do is solve for the theta there. Let's just quickly go over that. So the second part, our cos 2 theta is equal to negative 1. None of the cos of either of these angles were going to work. Cos of this angle would be root 3 over 2. And cos of this angle we've already dealt with 1 over 2. So we know that special triangle doesn't work. Same idea here. Both of these angles, because they're both 45 or pi over 4, are the exact same. So the cos of those angles, cos, keep forgetting not to do that, is going to be adjacent over hypotenuse, which is going to be 1 over root 2 or 1 over root 2. Neither of those are what we're looking for here with our negative 1. We know that's not going to work. So what we can do is we can take a look at our actual, okay, so we're going to create our cos wave, 90, 180, 270, 360, or known as pi over 2, pi, 3 pi over 2, or 2 pi. Now, technically I could go in the negative direction also, but if we go way back up to the beginning of this question, the instructions say to solve between 0 and 2 pi. So that's all I need to deal with this wave, because these waves technically go on forever. So I'm actually going to replace our degrees. We really don't need those because we're working in radians, okay? So I only need to go from this point here to this point here of the wave. Technically it goes on forever both ways, but I don't need to solve for that. If you remember our cos wave, just a normal cos wave, tops out at 1, or actually starts at 1. And bottoms at negative 1. So we have our cos wave starting at 0 and 1, so that's a major point. We have another point at pi over 2, and y is 0. We have another point at pi, negative 1. Another point at 3 pi over 2, and 0 again. And finally, the last point on here we have at 2 pi and positive 1. So let's just quickly draw our cos wave. So we've drawn our cos wave. If we go through all of our major points, the only time I have a y of negative 1 is when we're dealing with pi. This is our only example of it. Which is exactly what our question's asking, right? Cos of negative 1. So, again, we can get rid of the cos negative 1, just like we've done the cos in a half over there. We can drop the cos from the question now, because we know that it is equal to pi. So instead of having cos 2 theta equals negative 1, we get rid of the cos and the negative 1, because we've discovered what it's going to equal. Cos at negative 1 is pi. So now it becomes 2 theta is equal to pi. And to isolate theta, theta is equal to pi over 2. Does that make sense?